Hello everybody, and welcome to Lab 1A. So, I assume by now that you've already taken a look at Investigation 0A and 0B. Those are the investigations that I put together just to kind of give you a feel for the process of doing labs in the class and getting a feel a little bit more for some of the resources that we're going to be using. But now we're actually going to delve into the actual AMS Weather Studies labs. And so the first lab that we're going to do is Investigation 1A. So, to access Investigation 1A, there are 3 tabs that you need to have open. The first one is Canvas, and the Canvas tab should be on Modules, where you see our first module, and then to access Investigation 1A, you would click on Investigation 1A. And this then takes you to the page that has everything that you need. So, a little welcome message, a video demonstration, which I'm actually going to put right down here. I have a second video demonstration that goes a little bit more into what isobars are, but I'll talk about those a little bit in this video as well. The other 2 things that you need to have open are the textbook and the answer sheet for this investigation. And if you haven't yet purchased the textbook, you need to purchase it before starting this lab. And you can purchase it over at edubooks.ametsoc.org. And then once you've purchased it, to access it, you log in, click on My Account. Once you click on My Account, it'll actually take you straight to your library, showing you the books that you own. And then to access our textbook, click on Weather Studies Manual 2018-2019. You won't see the faculty version because you're a student, but you'll still be able to see everything that I see. And then click on Read Now. And I've already navigated to Investigation 1A. But before you continue, your screen should look something like this. Investigation 1A, Surface Air Pressure Patterns. Now before I continue, the other thing that you need to access is the answer sheet for this. So, the lab questions that are in the AMS Weather Studies Manual all come in the form of multiple choice questions. And to submit those multiple choice questions, there's a small Google Doc that you need to access, which then records your answers. So the link for that is right here. Click on that. And here is the form for Investigation 1A. And it has all the questions and everything that you need. Okay, now that we've got that pretty stuff out of the way, let's actually talk about the actual lab itself. Oh, actually, before I continue, one other thing I'll mention is that there are 2 plots that you're going to have to draw on, and you're going to have to submit those here in a file upload. So what you'll do is, on this page right here, on this Canvas page, at the bottom you'll see a file upload. Click on that, upload your pictures. You can either print the pictures out, take pictures on them with your phones, print them out and scan them, or another thing you can do is you can actually take the picture, upload it as a paint document, and using some kind of drawing or painting tool, do the diagrams you need that way. Either way is totally fine with me. Alright, so let's get started. So here is Investigation 1A. I should mention that this is probably the most difficult investigation of the entire quarter. And the reason why is because it has to deal with drawing what are called isobars. And isobars are very tricky. But if you've ever seen a topographic map before, or if you've ever seen a map with a bunch of squiggly lines on it that tell you heights or temperatures, isobaric maps are very similar to that. So really there's not much difference. With that said, they're tricky the first few times that you draw them. So give it a few times, make sure you can answer these questions, submit what you have, and once I take a look at what everybody has, I can then provide some feedback and we'll get you there. Alright, but before we do, let's actually talk a little bit about what an isobar is. So as meteorologists, we really care about pressure. And the reason why we really care about pressure is because pressure can greatly dictate the kind of weather we have. When pressures are low, that means there's rising air. That rising air can then create clouds and rainfall. On the other hand, if the pressure is high, that means there's a lot of sinking air. And if there's a lot of sinking air, that means there's going to be no clouds. It's going to be sunny, it's going to be dry. And so as meteorologists, we want to be able to identify areas where the pressure is high and where the pressure is low. Now, the easiest way to do this is record pressures all around the country and then throw them on a map. However, it could take a little bit of time to then identify, okay, where the highest pressure is, where the lowest pressure is. And so we have these little isobars that are ultimately a tool to help us visualize how pressure changes over the surface. And so that's what we're going to do right now. So first, when I say pressure in this lab, I'm talking about what's called sea level pressure. So most of the country, as I'm sure you know, isn't at sea level. And you also know, if you've ever been on an airplane and felt your ears pop, or if you've ever driven up Highway 17 down here in Silicon Valley and have felt your ears pop, or ridden on BART and felt your ears pop, pressure changes with height. Well, as meteorologists, we don't care about that pressure change with height. We only worry about where there's low pressure systems and where there's high pressure systems. And if we just took elevation into account, that would make it nearly impossible for us to identify high and low pressure systems. So we get rid of those. We get rid of elevation, and basically we take all pressure readings around the country and calibrate them to sea level. This involves using an equation that you won't need to worry about. But with that said, we're talking about sea level pressure. Now, once you do that, you end up getting a map that looks just like this map right here. Let me enlarge it a little bit. And there we go. And when you see a map like this, you see a lot of different numbers. And these numbers actually represent air pressure values. And the air pressure values are in a unit called millibars. All right, a unit called millibars. Now, with that said, and write this down, the average sea level pressure in millibars is 1,013.25 millibars. Actually, I'll even type that up here in my search engine. 0.25 millibars. That is the average sea level pressure. What I mean by that is that at sea level, the average pressure, the normal pressure, is 1,013.25 millibars. Anything lower than that, we consider that to be low pressure. Anything higher than that, we consider that to be high pressure. Now, with that said, when you look at this map, it looks kind of like information overload. There's a lot of information on here. There's a lot of stuff that you have to confront. But it's actually not that bad. So what I recommend when confronting a map like this, the first thing, take a few minutes and just take a look at it and try to identify where the highest pressure is and where the lowest pressure is. All right, so if you need a moment, you can pause, take a look, and get a feel for where the highest pressure is and where the lowest pressure is. All right, and assuming that you've done that, I can tell you that the lowest pressure is 1,006 millibars, whereas the highest pressure is down here, and there's actually a few locations that have it. The highest pressure is 1,035 millibars. So our lowest pressure is up here in the northeast of this map. Our highest pressure is down here in the west of the map. Now, in order to understand how pressure changes over location and how to identify areas of high and low pressure systems, we're now going to introduce what's called the isobar. And there's actually two of them already drawn on here. So an isobar is a line of constant pressure. What that means is that everywhere I travel on this line, the pressure remains the same. And this particular isobar is plotted for 1,008 millibars. So everywhere on this line, air pressure is 1,008 millibars. Now, a few things to know about these isobars. First off, these isobars act like a border. If you notice, everything north, there's only one number to the north, but it's good enough for now. Everything on one side is less than 1,008 millibars. And then if you look down here, everything on the other side is greater than 1,008 millibars. So these isobars divide areas of higher pressure from areas of lower pressure. And as you draw isobars, you want to make sure that the isobars you are drawing does that. If it doesn't do that, your isobar is somehow incorrect. And if you're confused or if you want feedback, please don't hesitate to email me what you have, and I can provide you some feedback. I can't give you the right answer, but I can provide you some feedback. So that's the first thing about these isobars. The next thing you need to know about these isobars is that these isobars have a difference between them. Right now, there's an isobar for 1,008 millibars, and then a second isobar for 1,012 millibars. The difference between these two is what we call the interval. And the interval is simply how many millibars you go between two of these isobars. So here we went from 1,008 to 1,012. That's a difference of 4 millibars. Now, based on that logic, the next isobar we would draw is for 1,016, then 1,020, and so on. And this is actually the normal American way of doing it. We draw isobars for every 4 millibars. And our isobars are divisible by 4. Don't believe me? Take 1,008 divided by 4. You get a whole number. Same thing with 1,012. If you're going to draw an isobar, in order to make sure that you're drawing the right one, take the number, divide it by 4. And that'll tell you if it's the correct isobar or not. Okay? Now, without further ado, let me actually show you how to draw isobars on this map, and then I'll get you started with the applications map. Alright, so what I'm going to do, I'm going to copy this image. You could print it out if you want to, but I'm copying it. And I'm going to open it up in a Microsoft Paint document. Yee. There we go. Alright? So, again, the very first thing you want to do, before you even draw isobars, identify where the lowest pressure is and where the highest pressure is. So here, I've already identified the lowest pressure is, let me extend that a little bit, 1,006 millibars. On the other hand, the highest pressure is 1,035 millibars. Now, in order to determine what isobars you're going to draw, you need to determine what numbers between 1,006 and 1,035 are divisible by 4. So is 1,006 divisible by 4? No. Is 1,007 divisible by 4? No. But 1,008 is. So we're going to draw an isobar for 1,008 millibars. Then, once you get that first one, all you really need to do is just keep adding 4. So, 1,012 millibars, 1,016 millibars, 1,020 millibars. Again, each one of these is divisible by 4, and I'm just adding 4 here. 1,024 millibars, 1,028 millibars, 1,032 millibars. And then once you get to where the next isobar is greater than your high, there you can stop. Okay, so we're going to plot isobars for 1,008, 1012, 1016, 1020, 1024, 1028, and 1032. Well, the people at the AMS were awesome to us. They already did 1008 and 1012 for us. Those are done. They did them for us. And if you can take a look, there they are right there. So now we are going to do 1016, then 1020, then 1024, and so on. So, here's how we're going to do it. Terrence, where would I know where to plot the 1016 millibar isobar? Well, look at where pressures are around 1016. So if I look over here, pressures are around 1030, 1035, 1028. It's not over here. Down here, pressures are 1020, 1022, 1019, not over here. Meanwhile, up here, look what I see. 1016, 1016. Up here I see some 1013s. Down here I see some 1018s, 1017. Over here I see a 1013 and a 1018. I'm thinking, and I'm pretty sure I'm correct here, that here is where my 1016 millibar isobar is going to go. So here's what we're going to do. The very first thing you want to do, in this case, using a brush, and I'm going to try to use a color similar to the one that the AMS used. Using a brush, you're going to put, and actually let me put a bigger dot. Using a brush, you're going to put a dot right in the middle of anywhere where it's 1016. And I see two places where it's 1016. Now the bad news is I don't really see anywhere else where it's exactly 1016. But what I can assume is that the pressure between 1013 and 1018, traveling from here where it's 1013, traveling down here to where it's 1018, somewhere in between these two, the pressure is going to be 1016. And chances are the pressure is going to be 1016, slightly closer to the 1018 location. Why? Because 1018 is slightly closer to 1016 than 1013 was. So I'm going to put a dot there. And then between 1013 and 1017, down here, same thing. Between 1013 and 1018, we're going to see the same thing. So it's going to be right there. You don't have to be 100% perfect on this. So don't worry if you're 100% perfect. I just want you to get the general idea of how this goes. Between 1013 and 1020, yep, somewhere in between those two, you're going to see 1016. And then again here between 1013 and 1020. And then here between 1013 and 1018. Boom. Now, is there anywhere else in this map that we could potentially see 1016? No. So what we can now do is simply connect our dots. Oops. If you want, you can actually just connect a line between them. And again, this doesn't have to be perfect. But here we go. We're connecting the dots, connecting the dots, connecting the dots. I kind of didn't connect that one there. There, I connected it now. And then once you're done, once you've drawn your line, you need to do two things. One, make sure that everything on one side is below 1016. So up here what I have is 1014, 1013, 1013. There's nothing up here that's above 1016. And then everything down here is above 1016. So I look 1017, 1018, 1020. There's no 1016s or anything lower than 1016 down here. So my isobar is good. The second thing you want to do is label the isobar. And let's do that. 1, 6. Done. We did it. And now everybody, 1016 is officially done. I can mark an X on it or a check mark. I'll do an X just to stay continuous. And now let's move on to 1020. So now we're doing the exact same thing. First off, Wherever it's 1020, I'm going to put a mark in. Wherever it's 1020, put in a mark. So 1020, 1020, 1020, 1020. Okay, so I feel like we almost have enough dots to draw the line. I kind of already have a good sense of where this line is. But just to stay continuous with what we did beforehand, let's look at a few other parts here. So 1018 to 1022. Somewhere halfway in between there, we're going to see a 1020. 1018 to 1021, we'll see a 1020 there. Let's see here. 1018 to 1024, oh, definitely we'll see a 1020 there. Probably closer to the 1018. And then 1018 to 1026, yeah, we'll definitely see a 1020 somewhere there. So there we go. And then, again, just connect the dots. Depending on the paint software you use or depending on your handwriting, I don't expect these to be perfect, so don't worry. I'm not looking for perfect artistic versions of this. I just want to see that you understand it. Okay, and then here we go. 10, 20, and we're done. Okay, now let's do 1024. So continuing on, we got 1020 done. Now let's do 1024. So the same thing. First, what you want to do, put dots wherever it is 1020. Or sorry, 1024. Put dots wherever it is 1024. I see one here. I see one here. See one here. I think this one kind of has a little bit more of an interesting shape to it. But this isn't really enough for me to get the perfect sense of where it's 1024. But again, what I can do, between 1020 and 1026, somewhere there it's going to be 1024. Because 1024 lies in between 1020 and 1026. Same thing here between 1020 and 1026. Same thing. Between 1023 and 1028, absolutely. We'll see 1020. We'll see 1024 there. Between 1022 and 1026, we'll see 1024 there. And between 1022 and 1026, same thing there. And now it looks like I have enough dots to connect this. And again, it's okay if they're not perfect. So here we go. And okay. So there's 1024. Done. All right. And you want to label it 1024. As you can tell, my handwriting is terrible on here. That's okay. All right. Next, we do 1030. So between 1026 and 1030, there'll be a 1028. Or sorry, next we'll do 1028. Here, we'll see a 1028 somewhere. Right here, there's a 1028. That's here. That's a 1026. That's a 1025. That's a 1026. 1029. So there'll be one right here. There'll be one right here. There'll be one right here. Right here. And again, somewhere between 1026 and 1030, you're going to see 1028. So right there, that'll actually be halfway in between. Between 1026 and 1031. So yeah, so you'll see it right there. And that's about it. Okay. So again, let's connect the dots. And there we go. 1028. Let me just double check just to make sure. So let's see, that was 1029, 1026. Let's hear everything on one side is greater than 1028. Everything on the other side is less than 1028. Done. And then finally, 1032. So we do the exact same thing. 1032. And we'll keep doing the same thing. And voila. There we go. Oops. I'll just undo that. Here, let me 1032. Okay, and done. And there we go. We've done it. Now we have everything. So the other questions left in the introduction section, you're going to have to identify where the winds are the strongest. That's going to be where these lines are packed closest together. That's where the pressure gradient is the highest. And then you'll see some other questions about this. But this is it for this diagram. I hope that you're able to follow me. And if you have any questions, please feel free to reach out to me. I'm going to do another video in a few minutes that just walks you through the first part of the application section.